Okay, let's do number 12 on the momentum and impulse sheet. Welcome back, physics fans. A zero point 0.6 kilogram green rubber ball is moving at 20 meters per second due east when it collides with a zero point 0.4 kilogram b-ball, basketball, which is at rest. During the collision, which lasts only 0.04 seconds, the green ball feels a force of 100 newtons. Okay, so this is east. Let's highlight that direction is east so that it just stands out because the first question is in a direction question. What is the direction of the force on the green ball? So here's the green ball and it's moving this way at 20 meters per second. We'll call that east. When it hits a basketball, and it's initially at rest, V is equal to 0. So it's hitting it. What is the direction of the force on the green ball? Okay, the force on the green ball hits the basketball and it hits it that way. So the force on the green ball will be the opposite direction. So A, the force's direction is west, the opposite direction. What is the green ball's change in momentum due to the collision? There you go. It sounds like a tough question, but its change in momentum is equal to the force times the time, the impulse. So this is the trick. I'm asking you for this, but you're going to calculate this. And since they are the same, that's how you're going to use it. So the force is 100 newtons, and that'll be to the west, times the time of 0.04 seconds, and that's going to equal 4 kilograms meters per second west. Also 4 Newton seconds west. C. What force must the basketball have experienced during this collision? Well, the basketball force, the force on the basketball, is going to also be 100 newtons, but that'll be to the east. Newton's third law, equal but opposite directions. What is the change in momentum on the basketball? Well, the change in momentum of the basketball has to equal negative the change in momentum of the green ball. Why? Because momentum is conserved. If one changes positively, then the other one has to change negatively. Because the total momentum has to be the total change in momentum, the total change in momentum has to be 0. If one goes up, then the other one has to go down. So since we have the change in momentum of the green ball, let's highlight it in green here. Then the change in momentum on the basketball would be then 4 kilograms meters per second east. And I'll highlight that in dusty rose red. It's the orangey red basketball. E. What is the total change momentum for both balls due to the collision? That would be 0. F. What, Mr. Girl? There is no F. Yes, there is. I want to know what is the final velocity of the basketball? We have its change in momentum. Its change in momentum is 4 kilograms meters per second east, and that has to equal m delta v. Oh, this is going to be easy, you say. Yes, it is going to be easy because its mass is 0.4 kg. So it's just going to be 4 kilograms meters per second divided by zero point 0.4. So the change in velocity is going to be 4 divided by zero point 0.4, which is equal to 10, and the units will be meters per second, and you'll still have that direction of east. So thanks for following along and doing this bonus question of F. And let's just recap what's going in. The green ball is coming in at 20 meters per second east, collides with the basketball, and it feels a 100 Newton force. Okay, and the basketball takes off from 0 to 10 going that way. So let's do question G. Mr. Curl, there's no G. I know what you're going to ask. Or do you? Think about 3 seconds. What am I going to ask here? What other piece of information do we not know that we could rifle from this question? I will pause this. Think about it. Exactly, the final velocity of the green ball. So we know its change in momentum is 4 kilograms meters per second west. Now, I know you guys, knowing Newton's laws, could say, well, okay, we have its initial velocity, we have its mass, we have the net force acting on it. We could calculate its acceleration, and then we can if we know the time, then we can calculate the change in velocity and find the velocities all using Newton's second law. Yes, we can, but I don't want you to. I want you to use the concept of the change in momentum. You'll see that it's a little easier. And we never needed to calculate the acceleration, which is important. Okay? The change in momentum of this is west, so it's going to be its mass times the change in velocity, and its mass is 0.6 kg, and its change in velocity is Vf minus Vi, and Vf is what we're trying to solve, minus Vi, minus, and what's the Vi? 20 east. Okay, and that has to equal 4 west. Okay, let me just scroll up and give ourselves enough room here to work on it. Okay, enjoy this. So I'm going to just skip the units now because it's getting all confusing here, but we can just put the units back in a moment. 4 is equal to 0.6 times Vf minus 20. Now it's 20 east, and this is west. So we should really call this, let's keep everything in the west maybe, or keep everything in the east, but just make sure that these numbers that we're putting in are in the same direction, then we can actually get rid of the units and stuff like that. So I'm going to say that, let's make it all east. So we'll make this negative 4 is equal to 0.6 Vf minus 20. Now, algebraically, this is going to be negative 4 divided by 0.6 is equal to VF minus 20. And Mr. Calculator, just so we don't make a little blunder here, 4 divided by 0.6 is going to be that number, and that's going to be a negative. And that's going to equal VF minus 20. So I'm going to add 20 to both sides. So it's 20 minus this number. 20 minus this number will be the final speed. And what is the direction of this guy? Well, we said that east was positive, so we didn't change this number. It was minus, it would have been not minus a negative. So we said east was positive, so this is a positive number, so we're still going to have it as east. Let's zoom out now and just take a look at this. I know it's really tiny now. Okay, probably don't need to zoom out that far. Let's go to 70%. So the ball is coming in at 20, and it's the green one. And it hits the little bit smaller basketball that's initially at rest, 0, and this came in at 20. And then after the collision, this green ball somehow is moving at 13 this way, and the red ball is only moving at 10. Okay? I would say that's a physical impossibility. That means the green ball kind of passed right through the red one. Thank you very much.